Welcome back, tech enthusiasts. Today, prepare for a mind-bending journey into the world of quantum computing revolution. It's a topic that has the potential to reshape our understanding of the world and redefine the boundaries of what is computationally possible. Let's set the stage by imagining a world where our computers operate not on the classical principles we're accustomed to, but on the strange and counterintuitive principles of quantum mechanics. This is the world of quantum computing, and it's closer than you might think. Quantum computing's roots can be traced back to the early 20th century, with the groundbreaking theories of quantum mechanics put forth by Max Planck and Albert Einstein. But it wasn't until the 1980s that the idea of quantum computers took shape, thanks to the visionary physicist Richard Feynman, who proposed that such computers could simulate quantum systems. Around the same time, David Deutsch introduced the concept of a universal quantum computer. So, what makes a quantum computer different from a classical one? The answer lies in the core concepts of quantum computing: quantum bits or qubits. Unlike classical bits, which can exist in a state of 0 or 1, qubits can exist in multiple states at once, thanks to a phenomenon called superposition. This allows quantum computers to process massive amounts of information in parallel. Picture a classical bit as a light switch that can be either on or off. A qubit, on the other hand, can be both on, off, or somewhere in between, like a magical light switch. Another key concept in quantum computing is entanglement. When qubits become entangled, the state of one instantaneously affects the state of the other, regardless of the distance between them. It's like a cosmic connection that transcends space and time. Fast forward to the present day, companies like IBM, Google, and Rigetti Computing are on the forefront of developing practical quantum computers. We're on the verge of a quantum computing revolution that could redefine the limits of computation. A landmark achievement in this journey is the attainment of quantum supremacy, where a quantum computer outperforms the most powerful classical computers. Google achieved this in 2019 with its Sycamore processor, marking a significant moment in the history of computing. So, where does this quantum leap take us? How will the advent of quantum computing impact the landscape of artificial intelligence? Experts predict that quantum computing will supercharge AI algorithms, enabling us to solve problems that are currently beyond our reach. From optimizing supply chains to revolutionizing drug discovery and redefining machine learning, the future is brimming with possibilities. Imagine a future where quantum and classical computers work together to usher in a new era of innovation. Let's rewind a bit and delve into the fascinating history of quantum computing. The genesis of quantum computing starts with the formidable theories of quantum mechanics, introduced by Max Planck and Albert Einstein in the early 20th century. These theories, which seemed almost mystical at the time, laid the groundwork for a whole new understanding of our universe. It was a world where particles could exist in multiple places at once, and actions could have instantaneous effects across vast distances. Now, imagine taking these mind-bending concepts and applying them to computing. That's exactly what physicist Richard Feynman proposed in the 1980s. Feynman envisioned a type of computer that operated on the principles of quantum mechanics. Unlike classical computers, which were limited by the laws of classical physics, Feynman's quantum computer could simulate quantum systems, a task far beyond the capabilities of any classical machine. Just a few years later, another physicist, David Deutsch, expanded on Feynman's ideas. Deutsch introduced the concept of a universal quantum computer. This was a machine that could not only simulate quantum systems, but could also perform any computation that a classical computer could. It was a bold vision that pushed the boundaries of what was thought possible in computing. But these were just the beginnings, the foundations for a field that would soon explode with innovation and discovery. As the 20th century came to a close, researchers began to unravel the mysteries of quantum mechanics and harness its power for computing. They developed new quantum algorithms, created the first quantum bits or qubits, and started to build the very first quantum computers. The path to quantum computing has been paved with curiosity, ingenuity, and sheer determination. It's a journey that has taken us from the abstract theories of quantum mechanics to the tangible reality of quantum computers and it's a journey that is far from over. Now that we know where it all started, let's dive into the core concepts of quantum computing. Let's delve into the world of qubits, superposition, and entanglement. Let's explore how these strange and wonderful phenomena give quantum computers their extraordinary power. And let's see where this quantum leap in computing might take us in the future. Opening. At the heart of quantum computing are qubits and the phenomenon of superposition. In the classical computing world, we're all familiar with bits, the fundamental units of information. They're like the light bulbs of computing, flicking on and off in a binary dance, representing either a 0 or a 1. But when we step into the quantum realm, we meet a new player, the qubit. What makes a qubit different? Well, it's all down to a peculiar quantum property known as superposition. Unlike a classical bit that can be either on or off, a qubit can be in a state where it is both on and off at the same time. It's a bit like having a light bulb that's both on and off simultaneously. Sounds impossible, right? But in the weird and wonderful world of quantum mechanics, it's not just possible, it's the norm. This superposition allows a single qubit to hold multiple states at once. Imagine having a book that can display all its pages at the same time. That's the kind of power we're talking about here. It's this ability that gives quantum computers their potential to process massive amounts of information simultaneously, making them exponentially more powerful than their classical counterparts. But let's dive a little deeper. Each qubit can exist in a superposition of states, with a certain probability of being found in each state when measured. But it's not a simple coin toss. The probabilities are determined by a wave function, and until a qubit is measured, we can't know for certain what state it will be in. It's like Schrödinger's cat, both alive and dead until you open the box. This might all sound incredibly abstract and quantum, but these principles are the key to unlocking a new era of computing power. Closing. But that's not all. Another bizarre concept awaits us: entanglement. When qubits become entangled, the state of one instantly affects the other, no matter the distance between them. This is the magic of entanglement, which is not just a concept from the realm of science fiction, but a fundamental principle of quantum mechanics. Entanglement is an eerie phenomenon that could have been dismissed as downright spooky, had it not been for its scientific validity and the potential it carries for quantum computing. It's like a cosmic connection that seems to defy space and time. Imagine two qubits, miles apart, yet so deeply connected that the state of one can instantly influence the other. This is not a teleportation trick, but the reality of quantum entanglement. This ability of entangled qubits to be inextricably linked leads to a level of synchronization that is impossible to achieve with classical bits. The implications of this for quantum computing are immense. A change in one qubit can instantaneously cause a change in another, no matter how far apart they are. This allows for a level of computational complexity and speed that is unattainable with classical computing. Now, imagine millions of these entangled qubits working together in a quantum computer. The computational power becomes astronomical, allowing for the processing of vast amounts of information at speeds that were previously unthinkable. This is the power of entanglement in quantum computing. It opens up possibilities for solving complex problems and performing calculations that would take classical computers thousands of years to complete. Moreover, entanglement could pave the way for new forms of quantum communication, potentially leading to networks that are more secure than anything we have today. It's an exciting prospect and a testament to the revolutionary potential of quantum computing. And yet, as mind-boggling as it might be, entanglement is just one piece of the quantum computing puzzle. There are still many challenges to overcome and many questions to answer. But one thing is clear: the quantum revolution is well underway. From theoretical concepts, we now move to the present day, where these concepts are becoming a reality. The journey of quantum computing continues, and it's a journey that we're all a part of. So buckle up, because the quantum future is closer than you might think. Today, companies like IBM, Google, and Rigetti Computing are developing practical quantum computers. These modern-day pioneers are creating a new frontier, pushing the boundaries of what we once thought was computationally possible. This era is an exciting one, where we've begun to witness the transition from theoretical quantum computing to practical application. But let's not forget, quantum computing is not a sprint, it's a marathon. Each incremental step brings us closer to a future where quantum computing might become as commonplace as the smartphones we use today. One of the most significant milestones in this journey is the achievement of quantum supremacy. This is when a quantum computer performs a task that even the most powerful classical computers would find impossible to complete within a reasonable time frame. In 2019, Google claimed to have reached this milestone with their quantum processor, Sycamore. According to them, Sycamore completed a task in 200 seconds that would take the world's fastest supercomputer 10,000 years to finish. This was a pivotal moment in the history of computing, marking the dawn of a new era where quantum computers could outperform their classical counterparts. But it's not just about speed. Quantum computers promise to solve complex problems in a fundamentally different way, potentially transforming fields like cryptography, optimization, and even drug discovery. So where does this quantum leap take us? What impact will quantum computing have on the landscape of artificial intelligence? Well, the possibilities are tantalizing. Experts predict that quantum computing could supercharge AI algorithms, enabling us to solve problems that are currently out of reach. Imagine optimizing supply chains on a global scale, revolutionizing drug discovery, or redefining machine learning. In the end, the journey of quantum computing is just beginning. As we continue to explore this uncharted territory, we can look forward to a future where quantum and classical computers work together, heralding a new era of innovation. Experts predict that quantum computing will supercharge AI algorithms, helping us solve complex problems that were previously out of reach. These powerful machines, unhindered by the limitations of classical computing, will enhance our processing capabilities, opening up a world of possibilities that we can only begin to fathom. Consider the potential in optimizing supply chains. Today, managing global supply chains is an immensely complex task, with countless variables and unforeseen disruptions. But with quantum computing, we could handle these variables simultaneously, allowing for highly efficient and resilient supply chains that adapt in real time to changes and disruptions. Then, there's the field of drug discovery, a process that can take years and billions of dollars. By leveraging the power of quantum computing, we could significantly speed up this process, accurately simulating the behavior of molecules and proteins to identify potential new drugs. Imagine the impact on healthcare, with new treatments and cures developed at a much faster rate. And let's not forget about machine learning. Quantum algorithms could redefine machine learning, enabling us to process vast amounts of data more efficiently and accurately. This could revolutionize fields like predictive analytics, natural language processing, and image recognition, among others. Even more exciting is the potential for quantum computing and classical computing to work together, each playing to their strengths. The vast computational power of quantum computers could be used to solve complex problems, while classical computers handle tasks they're best at, like managing data and running operating systems. This synergy could lead to a whole new level of technological advancement. So what does this all mean for us? It means we're on the cusp of a quantum revolution that could change the world as we know it. A revolution that will redefine our understanding of computation and its application. Imagine a future where quantum computers and classical computers join forces to usher in a new era of innovation. A future where the impossible becomes possible, where our wildest dreams of technological advancement become a reality. That future is not as far off as we might think. It's on the horizon, and it's coming faster than we can imagine. In conclusion, the quantum computing revolution holds immense potential for transforming our world. We've journeyed from the origins of quantum computing, rooted in the mind-boggling theories of quantum mechanics proposed by Einstein and Planck, to the introduction of the quantum computer concept by Feynman and Deutsch. We've delved into the strange world of qubits, superposition, and entanglement at the heart of quantum computing. Today, tech giants like IBM, Google, and Rigetti Computing are pushing the boundaries of what's possible, bringing us to the cusp of a quantum computing revolution that could redefine computational limits. Looking ahead, the impact of quantum computing on artificial intelligence could be profound, supercharging AI algorithms to tackle our toughest problems. Imagine a future where quantum and classical computers together inaugurate a new era of innovation. Thank you for joining us on this mind-bending journey into the quantum computing revolution. Until next time, stay curious, keep exploring, and keep learning.